introduce a new topic in this lesson called dividing polynomials. And there are two basic methods for dividing polynomials. You really need to know both of them. I know good and well you're not going to use this method on about 3/4 of them once I show you the next method, but sometimes this is the preferred method. Sometimes you run into polynomials where certain division problems can't be done using our little shortcut that we will learn in the next lesson. But we're going to be able to divide them. So the first problem we're going to do is 6x squared plus 7x plus 2 divided by the polynomial 2x plus 1. So that's our division problem. Reminder that a division problem can also be written like this: 6x squared plus 7x plus 2 over 2x plus 1. A totally legitimate other way to write that same problem. So we're going to do some division here. And we're going to start off by writing this as if it were a regular long division problem. 2x plus 1 divided into 6x squared plus 7x plus 2. So we're going to use long division to divide this. And I'm going to take a break here. We're going to stop right there and talk about what are we doing here. You probably haven't thought about that in forever. So let's come over here to the side and let's do just a plain old division problem. 672 divided by 21. Or you might have it written as 672 over 21. What are you doing if you do this by hand? Don't tell me you're typing it in your calculator. I know you can type it in your calculator. Let's do this by hand. Long division. If we wrote this out, you learned to do this in 3rd or 4th grade. 21 divided into 672. What did you do in order to do this division? Well, the first thing you said was, how many times does 21 go into 6? And it doesn't. So you moved over. How many times does 21 go into 67? And you said, okay, 21 goes into 67 3 times. And if I multiply 3 times 21, I get 63. So I write the 63 underneath the 67, and then what do I do? I subtract. You know how to do this. You just haven't thought about it in a long time. 7 minus 3 is 4, and then I bring down my 2. And then I'll repeat the process. How many times does 21 go into 42? Well, 21 goes into 42 twice. 2 times 21 is 42, and I subtract 42 minus 42 is 0. So I can make a couple of statements here. I can say that 21 is a factor of 672. And I can say that 21 times 32 is equal to 672. All right, so plain old division problem and what conclusions we can draw from that. Can we work this problem the same way? And we can. The first thing we do with this problem is we ask ourselves, how many times does 2x plus 1 go into 6x squared plus 7x plus 2? Well, how about we simplify that a little to start with, and we say, how many times does this 2x go into 6x squared? Or what would I have to multiply 2x by to get 6x squared? And the answer to that is 3x. And I'm going to do this whole step in red just to make the individual steps kind of obvious. So 2x times 3x is 6x squared. So that's the first term I want to find. Well, over here we said 21 went into 67 3 times, and so then we did 3 times 21 and got 63. I want to do 3x times 2x plus 1. You will often find that it simplifies things if you'll write that out here to the side, so you know what you're multiplying here. So I want to multiply 3x times 2x plus 1. When I do that, I get 6x squared plus 3x. I have simply distributed my 3x. And then what did I do next? In my problem over here, I did 3 times 21, got 63, drew my line, and then I subtracted. Well, I'm going to do the same thing here. 6x squared minus 6x squared is 0. 7x minus 3x is 4x, and then I bring down my 2. Well, there's my first step. Just like 21 into 67 went 3 times. 3 times 21 is 63. I brought down my remainder. Well, what about the next step? Well, let's just ask ourselves, once again, how many times does 2x go into the first term that I still have in my polynomial? So how many times does 2x go into 4x? What would I have to multiply 2x by to get 4x? And the answer there is 2. Again, I'm going to write this down out here to the side. I think it makes the multiplication easier to do here. So 2 times 2x is 4x, and 2 times 1 is 2. So I have multiplied that, and the next step is to subtract. And I got 0 for a remainder. The fact that I got 0 for a remainder tells us a couple of things. It tells us that 2x plus 1 is a factor of my original function. It tells me that 2x plus 1 is a factor of this 6x squared plus 7x plus 2. And it tells me that 6x squared plus 7x plus 2 factors as 3x plus 2 times 2x plus 1. So guess what I can do with those factors? Set them equal to 0, find my x-intercepts. All right, let's do another one of these using long division. And we're actually going to ask the question, is something a factor? So let's clear this and put in our question. Is x minus 2 a factor of x to the 5th minus 32? Well, how did we determine it was a factor a minute ago? We did division and ended up with a remainder of 0. If you end up with a remainder of 0, it is indeed a factor. So we need to do some long division here. So we're going to divide this x minus 2 into the polynomial x to the 5th minus 32. But we're going to use a little trick here. I don't want to just write x to the 5th minus 32. Makes my problem harder to do. I need all of the powers of x in this problem. Otherwise, I'm going to have a hard time with my subtraction. So make it a habit of filling in every missing term. There's no x to the 4th term. So write 0x to the 4th. There's no x cubed term. So plus 0x cubed. There's no x squared term. Plus 0x squared. There's no x term. Plus 0x. And then finally, minus 32. This is going to be a long division problem. But we're going to just do it one step at a time using exactly the same methods we used a minute ago. So the first question, how many times does x go into x to the 5th? And it goes in there x to the 4th times. I'm going to continue through this problem writing these little expressions out to the side to make it a little easier. I need to multiply x to the 4th times x minus 2. And that gives me x to the 5th minus 2x to the 4th. Now be careful here with your subtraction. Remember, you're subtracting every time. So when I subtract x to the 5th minus x to the 5th, it gives me 0. That first term should always eliminate. 0 minus a negative 2x to the 4th gives me a positive 2x to the 4th. So be aware of that. Bring down your next term. And then we just repeat. How many times does x go into the first term that I have down here, 2x to the 4th? What would I have to multiply x by to get 2x to the 4th? Well, that would be 2x cubed. So multiply 2x cubed by x minus 2, and I get 2x to the 4th minus 4x cubed. And subtract. 2x to the 4th minus 2x to the 4th is 0. 0 minus 4x cubed is positive 4x cubed. Bring down my next term. we're going to keep doing this until we can't divide anymore. So sometimes you do this a whole bunch of times. So we'll change the blue here. How many times does x go into 4x cubed? 4x squared times plus 4x squared. Multiply 4x squared times x minus 2. And we get 4x cubed minus 8x squared. It's a little monotonous on a problem this long. And we subtract. 0 minus 8 is 8x squared. Bring in your next term, 0x. And we're ready to start our process over again. Yellow didn't show up. Let's use black here. How many times does x go into the first term? 8x squared. What would I have to multiply x by to get 8x squared? Well, 8x plus 8x. Okay, that's an 8. So 8x times x minus 2 gives me 8x squared minus 16x. And I subtract. 16x minus 32. And then round last time. So how many times does x go into 16x? 16 times plus 16. So 16 times x minus 2 is 16x minus 32. And we subtract 16x minus 16x is 0. Negative 32 minus a negative 32 is 0. I got a remainder of 0. So the answer to my question is yes, absolutely. X minus 2 is a factor of x to the 5th minus 32. And in fact, I can rewrite this function as f of x is equal to x minus 2 times what I got when I did my division. X to the 4th plus 2x cubed plus 4x squared plus 8x plus 16. I have factored that and determined that x minus 2 is a factor of x to the 5th minus 32. Long division. There are shorter ways to do problems like this. We'll look at that in the next video. But like the problem that we did in the last one is usually easier to do with long division. So there are advantages to both of them. This one is long division of a polynomial.